Good morning, everyone, and welcome to the Fiber Broadband Association's Fiber for Breakfast. We're now in our 31st episode of 2022. Before I kick off, I'd like to thank our sponsors of Fiber and Breakfast, including our gold sponsors, Graybar and Vetro. Earlier this week, RUS announced its fourth round of Reconnect funding. This is the second round of Reconnect funding in this fiscal year. RUS received additional funding for the broadband from IIJA, and the third round of funding actually saw 305 applicants requesting a total of $4.8 billion. So the interest in Reconnect funding is outpacing the 1.15 billion that was allocated in that round. Today I'm in Denver to meet with NTIA and the state broadband directors representing 56 states and territories. They all have a huge job in front of them. We want to provide as much support as possible, as it is imperative that the BEAD program is successful in getting critical broadband infrastructure deployed to all Americans. Speaking of Colorado, we're going to be back here in a few weeks for our Regional Fiber Connect event at Copper Mountain on August 23rd. Registrations for Copper Mountain are way ahead of our past events, so please register today, as you won't want to miss it. Our last regional event workshop for 2022 will be in Columbus, Ohio on November 3rd. Again, these regional events continue to gain tremendous momentum, so please don't wait to register, as they will be sold out. Speaking of standing room only, today's Fiber for Breakfast session has drawn a near record crowd to discuss the limits of fixed wireless technology for rural communities with Dr. Andrew Afflerbach, the CEO, CTO of CTC. That's a whole lot of C's there. But before I formally introduce today's guests, I'd like to introduce Trish Ehlers of our team, who's going to walk us through some housekeeping items.
Thanks, Gary, and good morning to everyone who's joined us this morning. Before I go over a few logistical items, I'd like to once again thank our Fiber for Breakfast Gold sponsors, Graybar and Vetro. And now if everyone would just keep in mind that you're all in listen mode only. To ask a question, simply type it into the question box located within your control panel on the right side of your screen. We'll host a Q&A session with our panelists at the end of today's webinar. This presentation is being recorded and will be available to members only on FBA's website within 24 hours. You can find the recording in the Events tab under the Fiber for Breakfast drop-down option. At the conclusion of the presentation, you'll be prompted to complete a very brief feedback survey. If you could take a minute to do so, we really do appreciate your input. I'll pass it back to Gary now to introduce our panelists and get us started. Gary?
Thanks, Trish. And good morning. I'm Gary Bolton, the President and CEO of the Fiber Broadband Association. Last week at Fiber for Breakfast, we discussed revitalizing Appalachian communities through broadband with Curtis Hanson from the Appalachian Regional Commission. I love the work that Curtis and ARC are doing to improve the quality of life in the Appalachia. To me, this is what broadband is all about. Today, we're going to shift gears a bit and focus on technology in an effort to ensure our unserved and underserved communities don't get shortchanged. In today's Fiber for Breakfast, we will discuss the limits of fixed wireless technology for rural communities with Dr. Andrew Afflerbach, the CEO and CTO of CTC. Dr. Andrew Afflerbach is a licensed professional engineer and specializes in planning, designing, and implementing oversight of fiber and wireless broadband communication networks, smart city strategies, and public safety networks. He is an experienced network planner who understands the business and financial implications of various network designs and has delivered strategic technical guidance on wired and wireless communications issues to cities, states, and national governments. As CTC's Chief Technical Officer, Andrew oversees all technical analysis and engineering performed by the firm. With over 25 years of broadband experience, Andrew testifies as an expert witness on broadband communication issues and is frequently consulted on critical communications policy issues throughout technical analysis submitted to the FCC and policymakers. So welcome, Andrew. And for our audience, please type in your questions as we go, and we'll work them into the Q&A at the end. With that, I'd love to turn it over to Andrew.
Thanks, and I'd like to thank the FPA for organizing this this talk. And there's a whole lot here to go into. So if your question doesn't get addressed here, if there's a way you can send that up in writing, I'd love to communicate back with any of you, because there's a lot to talk about and many sides to the picture here. I do want to emphasize that this talk is primarily about rural broadband delivery in detail. You can go to the Benton Foundation website to get hold of the whole 150-page report, and you can get into this at the level of detail that you're interested in or that suits you. What I'd like to talk about today are the wireless and fiber technologies, how much bandwidth is actually needed, because that's a question that I think policymakers come up with quite frequently. We know that certain technologies and certain setups can do certain things, but how much is really something that a household would really need now and in the future. And then some cost models that we've gone into. Prior to this work, a lot of the discussion on fixed wireless and fiber has been on not apples to apples comparisons, and frequently not in any sort of detailed models that take multiple facets into account, including the complexity of building both the technologies, the specifics of certain rural environments. And so we've done very specific scenarios ranging from a small town to very low density, and come up with, I think, some interesting results that we're still beginning to unpack the details of. Next slide, please. The short 30-second summary is essentially that fiber, as you're aware, provides many factors more capacity simply because of the physics of the material, and because of the ability to scale the bandwidth with simply changing out the equipment at the ends, has a very clear path going forward for as far as capacity and capabilities. In the long term, we find that the fiber and fixed wireless costs are comparable. This study focuses on the 30-year total cost of operations, but we break out the cap and OpEx costs, so you can kind of look at the details of how those work out. And although in most cases you have a low capital cost for fiber for fixed wireless installation, although not always, you do have frequent replacement of a larger part of the system, which makes the difference. And finally, just the complexity of serving with the two different types of technologies. The complexity is on average lower with a fiber technology, taking into account a lot of the facets that I'll go into in more detail. Next slide. So here we have a rural fixed wireless scenario where you would have the use of a tower, perhaps a grain silo, perhaps even using one of the customer premises to serve the surrounding areas. And depending on the density of the area and the spectrum available and the specific layout, you can use a single site to serve up to hundreds of users. Next slide. And there are some very interesting and positive developments in wireless technologies. As many of you are aware, spectrum is often a challenge. You have unlicensed spectrum, which has to be shared with whoever comes to the game. Many of the fixed wireless providers don't have access to licensed technology. It kind of depends on the provider and on the area. So you have to find ways to work around the limitations of spectrum. And there's some very strong technical approaches, including MIMO, which actually makes a friend of reflections and multi-path communications, and can increase the performance and reliabilities and capabilities of wireless communications. massive MIMO technologies are used by many different wireless providers now and are getting a whole lot more value out of wireless communications. There's also beamforming technologies, which allows you to take a certain batch of spectrum that are available, and rather than just radiating it in all the directions at once, you can lock onto particular areas and actually reuse that spectrum. It improves both the capacity and the quality of the signals. Next slide. Another important fact in wireless communications is you have a trade-off in spectrum. The short story is essentially you get much higher capacity with higher frequency signals like millimeter wave, and this has to do with a number of factors, including the width of the channels. The downside of those high frequency communications is you have a signal that's more like light, more like a laser beam, and therefore what happens is that rather than like radio where you can communicate with a lack of line of sight around hills and around trees. As you get to the very high frequencies like millimeter wave, you're much more dependent on strict line of sight. So a wireless provider has to basically play a balancing game and optimize for the spectrum in their particular situations. What this means is that in a rural setting, it's very, very challenging to use something like the very high frequency, high speed communications, and you're using more like the mid-band and the low-band communications, which can work with a certain amount of challenge with line of sight and foliage. Next slide. How much bandwidth do we actually need, though? I mean, how critical is it to have a gig that we're all excited about? Well, today I think it's fair to say that nobody really uses a gig in their household, very few people at least. And so here we have a simulation of peak time for a household. On the left-hand side, you have during the daytime, and the right-hand side, you have in the evening, where in theory, at least, people are more likely doing entertainment and less working. And what you see here is you're pushing the limits of what the FCC had said was acceptable broadband, 25 by 3, and you especially see the challenge in the upstream direction that comes from distance learning, remote classroom, and a lot of the time when you're working with something like Teams or Zoom and things start to get fuzzy, it's really the upstream that's creating the problem. So a network developer looking forward should really be thinking about both of these. Next slide. The other thing that we should all be thinking about is that when we're thinking about BEAD and IIJA, we're talking about infrastructure for 10 years, 20 years. And so what we're doing right now is really just about as relevant as what, 10 years, 20 years ago, when many of us were working with dial-up and some of us were doing quite fine with it. What we're seeing on the horizon is the development of technologies like Web 3.0, augmented virtual reality, which is going to become not just for the gamers, but for people who are doing remote medicine, people who are doing training and other sorts of education and so forth, are going to be requiring a lot of upstream bandwidth as well as downstream. So if we're looking something like 10 years in the future, and if we're looking at a technology which is really just the middle of the road estimates that the people, the community are looking at, we're looking at a household of 4 being well into the 400 megabits per second range, both upstream and downstream. And then of course, a very large family or small business environment, we're pushing beyond a gig. And the assumptions are detailed a little bit more in the report that we're providing. But again, this is just a mild amount of the interactive type of communications with Web 3.0. Next slide. So you have to have a technology that's going to work with that. And we have a breakdown here on the slide here with the range of not just the cut sheet capability of communications, but in an actual operational environment. We're all aware that the actual speed of communications you get depends on a lot of factors, including the loading of the network or your line of sight or a lot of issues that are just like specific to the implementation. So we have a range here with fiber basically leading the pack up to 10 gigs with off-the-shelf equipment that without too many assumptions about any sorts of special kits or preparation to get to particularly high speed. We have cable communications, cable DOCSIS 3.1, which is the off-the-shelf available. This is all the downstream speeds, of course, with a gig or pushing maybe up to 2 gigs, and the capability with the next generation of pushing up to 10. If we look in the wireless realm, we see similar speeds with millimeter wave communications, but as mentioned before, a lot of challenge using that in wireless because of its short range, and it's very dependent on the types of line of sight that you get. If we look at what's available in the rural realm, we have the 5G fixed wireless. I'm speaking more broadly there. That includes proprietary technologies like Tirana, which are have a lot of 5G capabilities, but they're not standard compliant 5G. And there you are also able, in many circumstances, to push up to hundreds of megabits per second in some scenarios. Same thing with the 5G, but you're not able to push to the multi-gig. You're not able to push way beyond that with the current technologies we have. Again, limitations of spectrum and line of sight. Next slide. The challenge is more acute in the upstream direction, and there are many ways with wireless to try to improve your upstream performance, including in the allocation of spectrum between the up and down directions. But basically, the gap widens in general when we're looking at upstream, which, as mentioned, is going to be increasingly important and is already very important for the interactive communications. So I think that an evaluator of grant funding and policy has to really focus on this upstream piece as well as the downstream piece. Next slide. So, you know, when we're approaching fixed wireless, we're approaching a technology where a lot has to go on to make it really work properly. And so what we're going to be saying here is that if we're going to switch from what in the past had been the frequent fixed wireless scenario to one that is more like what we were going to have with BEAD, where you really have to blanket a service area with a set type of service, and you have to cover everybody, not just the people with good line of sight. The applicant for that grant or the provider that's looking to do this has to double down in terms of making sure that the line of sight is going to be available. Has got to make sure that spectrum is available, which again is something that you can't always predict if you're unlicensed, or CBRS has to take into account the complexities that you might have with weather and so forth. And so what we're finding is that in order to really make this work in the simulations that we've done, it requires a lot of different antenna locations spread out. And in a rural environment, although in many cases you can save money with fixed wireless, you're also running into scenarios where you're going to have to put up an antenna where there are no antennas, and where that antenna is only going to serve a small number of users, simply because there aren't that many out there. Next slide. So also coverage versus capacity. When you're doing a wireless model, it's possible to get signal. In other words, to have a certain amount of bars on your phone, but the SIP model has to also include your capacity. So here's an example of, in our report, we look at Deming, New Mexico, and we find that that's an example of a place where everybody can get signal if you put up one site, but to get the amount of capacity that's needed, we're looking at 10 separate sites on towers or buildings or whatever have you, to make sure that you are delivering the required 100 megabit per second service. Next slide. So the report that we prepared has 4 different scenarios. Deming is the small town scenario, and then we have gradations in density, because everyone is involved with network design, whether it's in fiber or in wireless. Density is really the #1 driver in costs. We run all 4 scenarios. Next slide. And the outcome that we find is I think some things that many of us know, some things that are a little twist on what we know already. When we're looking at fiber, we have higher capital costs, and most of the costs for fiber relating to construction costs. We find that the capital costs for fixed wireless are primarily the customer premises equipment costs. And in rural areas, another large factor is going and having to add either tower sites or antenna sites on silos and so forth that in many cases serve relatively few locations. In operational costs, we find that in the fixed wireless realm, 40 to 80% is basically what you have to set aside for the investment in going up to the next level of technology. Again, if most of your cost is the CPEs, to take those CPEs to the next generation is a lot of ongoing dollars going in. So whoever is going to be picking fixed wireless as a solution for long-term broadband for 20, 30 years has to take into account that equipment replacement or upgrade. Whereas in the fiber realm, you are replacing the end equipment. You're going from BPON to GPON to so forth to the higher technologies. But the electronics is only 1 to 10% of the capital cost of the fiber network. So that's where it all changes. Next, just to get towards the end of the presentation, next slide. So again, we have a range of costs that would be in place. For example, in fiber, you're going to have a range of construction costs depending on whether you're the incumbent phone company leveraging your existing plant versus if you're building new and you're digging through a mountainside and so forth. So we always have a range, but we find if we're taking the 30-year view, if we're including the total cost of operations, you can see this significant overlap here in the cost of the FTTP scenario versus the fixed wireless scenario. Next slide and final slide. So to conclude, what we find is that essentially if we have similar costs of total cost of operations, and if, again, what we're talking about is not just a broadband scenario for the next 5 or 10 years, for much longer, we think that fiber in most scenarios is the way to look at, because what we have is a technology that is stronger in terms of being scalable and renewable. We have fiber, which itself can support the wireless technologies going forward and be this foundational technology. And the importance that if we are going in a hybrid approach, or if we're going in a fixed wireless approach, to make sure that the approach that's taken has an appropriate roadmap and has a budget set aside for whatever type of equipment replacements and upgrades that need to happen. So with that, I'll take a breath and hopefully take some questions from the group, and thank you all for spending the morning with me.
Andrew, thank you so much. Really interesting. I thought it was a great report when I saw it come out with Benton. When we look at BEAD program, getting our critical infrastructure out, there's not an OpEx component, right? It's the funding is for CapEx, so it would be, we could end up with tumbleweeds networks, right? If these, state programs don't take into consideration the ongoing OpEx. Is that the way you guys see it?
I mean, that would be the concern. And there are a lot of ways to skin this cat and people with innovative business models. But my encouragement to somebody who is either on the planning side or on the evaluation side is to make sure that somehow the big picture is taken into account, and that you don't have your constituents 10, 15 years down the road knocking on the door saying, hey, what happened to my broadband? I'm back to where I was.
Yeah, absolutely. And one of the things I thought you guys did a good job in your report is pulling out for state broadband offices to look not only at the first cost, but over the capital costs of 5, 10, 15, 20 years, the OpEx cost 5, 10, 20, 15 years. But you also mentioned resiliency, which is part of the BEAD consideration. And what are your comments on fiber versus fixed wireless from a resiliency perspective?
Well, again, I would say the importance would be looking at the specific implementation of the model fiber, you know, is as we know, hard to kill. There are a lot of scenarios where we've seen the poles get knocked down and the fiber actually continues to operate over that. And then with fiber to the premises, if the end customer has backup power at their location, they're able to keep operating when the power goes out, which is, you know, I think a very strong thing to say about that. With fixed wireless, I think one of the weaknesses is if you have what's called the like the point to multi-point approach, where you're just getting signal from one location, that location at the base station point, if you will, is a single point of failure for everything around it. And so with fixed wireless, that can be remedied with a mesh type approach. And so there are technologies coming down the pike that will feed back multiple different directions. And we're seeing more and more of that, particularly in an urban and dense suburban type setting. But in a rural area where it's really hard just to get one antenna to reach you, I think that becomes very, very hard to guarantee resilience, because you are lucky just to have the one line of sight working.
Well, we have a ton of questions here. So where do you see fixed wireless technology, or how do you see addressing line of sight barriers?
Well, I think that, again, to address that, the MIMO technologies help. So as the technologies continue to go into future generations, I think that that's going to improve the capabilities, and then, you know, over time, having a denser layout of both base station antennas and the capability for the various you know, other customers to kind of relay among each other. One thing I would highly caution, though, is that there are some, you know, there's a range, like in any kind of technology in the fixed wireless realm, where there are providers who basically think nothing of, I'm going to attach to a tree here, I'm going to attach to something that's just kind of sitting in the lawn here and whatever. And so if you are using relay points with intermediate customers, it's really important that those intermediate customers are beholden to very long-term contracts, that they have backup power at their locations, and that the installation that they have there, even though it may be on them as a residence, is basically a commercial grade installation where they are.
So we also, this is more of a comment, but it's, you know, thanks for pointing out the importance of upstream capacity for the future, and highlighting telehealth as you know, has a lot of potential in the rural setting, and that's upstream is critical for that. Do your cost models, let me get my glasses on for this one. Do your cost models take into account the fact that you want fiber between the antenna towers, or do the models assume wireless for the middle mile backhaul?
There's a flat dollar amount there for backhaul, and the assumption is it's going to be a hybrid, that usually wireless providers are going to fiber where they can, and then do point-to-point communications for backhaul where the fiber is not available, or to do a resilience to maybe do both of them. But there's essentially an average dollar amount that assumes that the backhaul is going to be some of each.
So we're kind of running out of time. So what would you tell state broadband offices, or who are considering fixed wireless technology over fiber to the home as being more cost effective in establishing their scoring metrics for grants?
I think it'd be really important that they have to be assured very strongly, not just that there's coverage, in other words, signal at a location, but also that the solution is going to provide the capacity right now for you know, the bandwidth threshold that's needed, assuming that the network is loaded and you have all these different individuals connected to the network, and that there's a roadmap going forward, both for just replacement of the technology as the components get old, and also to go to, you know, the next G, or the next generation, if you will, of the technology. But I'm finding that it's I've not been reassured in many cases by proposals that I've seen for fixed wireless in rural areas, where there's certain people that, you know, are just difficult to serve and they're left out because they're in a valley or because they're behind trees and so forth. And there has to be an assurance that they're not just going to be glibly told, well, you should just chop down all your trees, or, you know, you should just allow us to charge you for an $80 pole or something along those lines. There has to be, you know, assurance that this is a real approach that's not going to create a hardship for the people who are receiving the service, and that the quality is going to stay up over time. It really is doable in a lot of cases, but I would say that broadband planner has to hold the bar up high, both for the fiber and for the fixed wireless applicants.
Yeah, when you think about BEAD, it's different than the FCC programs. You know, hitting minimum speeds, FCC, where there's money coming year after year, and you can just keep subsidizing the same areas over and over, moving from 4.1 to 10.1 to 25.3 and so forth. BEAD, this is it. This is one time. This is infrastructure. And so we can't look at just what it takes to hit the minimum speed. We really have to build up for the future. I'm going to sneak one more question in because I think it's interesting, but what impact does wireless last mile and wireless middle mile have on latency?
Yeah, so the latency depends on a lot of different factors in wireless. Some of it has to do with the software and the approach that's used to basically allow all the multiple upstream and downstream people to communicate at the same time. And so there are some fixed wireless solutions where latency is pushed up to 40, 50 milliseconds, and that is longer than the 10 milliseconds that you can get with fiber, and usually about 20 that you get from cable. So I would hope that as time goes on, that the fixed wireless technologies would, you know, tighten that up considerably, because there are a lot of issues that can happen. You have the longer latency, not just the performance of the applications where you don't want to have a delay, but also that you can start to build up problems with buffering and things that just lead to very poor performance. So it is a place that is of concern to me right now in the fixed wireless area, but I hope would be improved over time.
Yeah, I mean, as we move into these gigabit networks, latency is king. That's going to be the long pole in the tent. So we got to definitely keep a close eye on that. Andrew, thank you so much. Really appreciate the amazing work that you and your team are doing with the states and with communities around the country. Thanks for your work on this white paper, and really appreciate everything that you guys have done. I want to thank our audience for joining us today, and I look forward to getting back together next Wednesday. We're going to be discussing an open access network in the Empire State with Mayor William Acey of the village of Sherborne in Chenango County, New York. So you're not going to want to miss that. And then we have a ton of questions here, so Andrew, we'll get those to you, and hopefully you can answer those by email. But thanks everyone for joining us today, and we'll see you guys again next Wednesday.
Great, thanks everyone.